Welcome to OPENBOX Education. In this video, I am going to explain about stack structure in Hadoop. If you like this video, please subscribe to my channel and share to your friends. A stack is a linear data structure that stores a set of elements in a sequential manner. In stack, new elements can be inserted and existing elements are deleted to or from only one end called top of the stack. That is, here in the stack we can delete or we can insert the elements into the stack in only one way. So it follows LIFO procedure. Here LIFO procedure is nothing but last in first out. That is, the last element which is inserted into the stack, that will be eliminated or that will be removed from the stack first. There is no constraint on the number of elements to be stored in the stack. So whenever the elements are inserted into the stack size will be grows, and when the deletion is happened, the stack size will be shrinked. So here this is the representation of the stack. So here only the one way to insert the elements into the stack, and there is only one way to delete the elements from the stack. So here the elements here within the stack, that is, the first one is that 50, and second one is that 80, and third one is the 30, and last element is the 10. So this stack will follows that LIFO order, that is last in first out. So this is the last element which is inserted into the stack, so that will be removed from the stack first. So generally here this 10 element representing that the top of the stack. The next one is that primitive operations on stack. So the first one is that insertion operation. So the method of inserting the elements into a stack is called push operation. It adds a new item on the top of the stack. So top is incremented by 1 each time when an element is inserted onto the stack. So stack is also known as last in first out structure, where the element inserted at the last is the first to be deleted. So what we are discussing in the last slide, the same point here. And push operation is nothing but writing values onto the stack or into the stack. When stack is full, no element can be inserted, and this situation is called stack overflow. And next primitive operation is that deletion operation. So the method of deleting an element from a stack is called pop operation. It deletes the topmost element present in the stack. Top is decremented by 1 each time when the element is deleted from the stack. So generally pop operation is nothing but deleting values from the stack. So when the stack is empty, no element can be deleted, and this situation is called underflow. So these are the two primitive operations on stack. So now we will go for an example. So consider an example to illustrate how push and pop operation are performed on a stack. So let us assume that the elements here we have 50, 80, 30, 10 are required to be inserted into the stack. So initially the stack is empty. And the top of the stack pointer shows that -1. So here it is a very important point. When the stack is empty, the stack pointer value is -1. So when the 50 element is inserted, the stack value will be incremented from -1 to 0. Now the top of the stack is 0, and after that the element 80 will be inserted, then the top of the stack will be incremented by 1, and next 30 is inserted, then the top of the stack is now 2, and next 10 element is inserted, the top of the stack is 3. When the element 10 is deleted and the top of the stack will be decremented by 1, now the top of the stack is 2. And next when the element 30 is deleted, then here the top of the stack will be decremented by 1. Now the top of the stack is 1. So here the methods for implementing the stack interface as follows. So here this is the first instruction, which is representing that creation of an empty stack, and second one is that s1.push. So this method adds element to the top of the stack. So here one example is there, s1.push1, s1.push2. If you are using these two commands, then the stack will contains that element 1 and element 2. And for pop operation, we'll go for s1.pop, then it simply removes the elements within the stack. And next one is that s1.peek. then this method gets element present on top of the stack without deleting it. So the syntax is given as that head equal to s1 dot peak. So thank you very much for watching this video. To watch more videos, please subscribe to my channel OPENBOX Education.